Hello. In this lecture, we will study about the biasing of the junction diodes. Biasing means how the connections are made, how we connect the junction diode with the terminals of the battery. There are two types of biasing, forward biasing and reverse biasing. In forward biasing, the P-type semiconductor is connected with the positive terminal of the battery and N-type is connected with the negative terminal of the battery. In terms of the symbol, this arrow represents the p-type and this line represents the n-type. P is connected with the positive terminal, N is connected with the negative terminal through resistance. So it is a forward biasing diagram. Now, in case of the forward biasing, as P is connected with the positive terminal of the battery, the positive terminal exerts a repulsive force on the holes. As a result, the holes moves towards the junction. And the negative terminal exerts the repulsive force on the electron. As a result, both the holes and the electrons are moving towards the junction and the width of the depletion region decreases. As the width decreases, the number of the charge carriers are able to cross the junction. In terms of the potential barrier, it is the potential of the p-type and this one is the potential of the n-type. So the height of the potential barrier is initially V0. Now applied potential is V. As it decreases the width, so the height of the new potential barrier is now V0 minus V. As the height of the potential barrier decreases, the majority carriers are able to cross the junction. So we can say in forward biasing, the current is due to the majority charge carriers. Now the reverse biasing. Now the reverse biasing. In reverse biasing, the P region is connected with the negative terminal of the battery and N is connected with the positive terminal of the battery. In terms of the symbols, it is the P, it is N. P is connected with the negative terminal and N is connected with the positive terminal of the battery. So it is a circuit diagram. Now as it is connected, P is connected with the negative terminal. So the negative potential of the battery attracts the holes towards itself, and in the N region, the positive potential attracts the electron towards itself. As a result, the electrons and the holes are moving away from the junction and increases the width of the depletion region. As the width of the depletion region is increased, the very few majority carriers are able to cross the junction. But the potential barrier allows the minority carriers to cross the junction. And you know that the minority carriers are the thermally generated. It depends on the temperature. So their number is constant. So the current is constant in the reverse biasing. Now the characteristics. Characteristics mean the graph between the current and the potential. When diode is forward biased and when diode is reverse biased. It is a circuit diagram of the junction diode when it is forward biased along with the voltmeter and the milliammeter. The applied voltage is increased gradually and the corresponding value of the forward current is recorded. The graph is plotted between the forward bias voltage and the forward current, and it is as shown in the diagram. It is the forward characteristic graph. Now it is clear from the graph that when the forward bias voltage is small and less than the barrier potential, the current is small. And as V is increased till it is sufficient to overcome the potential barrier, the current increases sharply beyond VR, called the knee voltage. This is called the knee voltage. The slope, the current beyond the knee voltage, the current increases almost linearly. The slope of this graph gives the resistance of the diode in forward biasing. Now it is the circuit diagram for the reverse biasing along with the microammeter and the voltmeter. If the reverse voltage is increased, the reverse current is almost constant. But after certain value, there is an abrupt increase in the reverse current. This value of the reverse bias voltage is called breakdown voltage. And at this voltage, the avalanche takes place. The large number of the electrons are coming out from the semiconductor and the very large current is flowing, and this phenomena is called avalanche breakdown. The value of the breakdown voltage depends on the level of doping in the two regions of the junction diode. The IV characteristic verify that the forward bias resistance is very low as compared to the reverse bias resistance. This property is used for converting the AC voltage into the DC voltage. In the case of the reverse bias, the resistance, which is equal to the change in the potential to the change in current. As in reverse bias, change in current is almost zero, so we can say the resistance is infinite. And in forward biasing, the resistance is very small. As the resistance is not fixed, it is varying. So this type of the resistance is called dynamic resistance and is measured as the ratio of the change in the potential to the change in current. Thank you and have a nice day.